In 5.1, we're going to classify polynomials by degree and number of terms. So here's a chart that might come in handy. Take a picture of it if you'd like, so you can have that out and have that next to you as we go through some of these problems. I'm going to have this chart out so I can see it. The directions say name each polynomial by degree and number of terms. So notice I'm using red and blue because of the chart, red numbers and blue numbers. We're going to find the degree by the highest exponent, okay, the exponent on the variable. So this is a degree 2, so find the red number 2 in that chart. That makes this a quadratic. Now for the blue, the number of terms, there's only one term, so find the blue number 1. That makes this a monomial. This is a quadratic monomial. Problem number 2. The highest power makes this a degree 3, so this thing is a cubic. And then there are 1, 2, 3 terms. Blue 3 makes this a trinomial. So number 2 is a cubic trinomial. All of these problems work in the same way. The next one's kind of hard to see because you may not see that exponent 1, but that is an exponent 1. This is a degree 1, so this is a linear, and there's only one term, making it a monomial. Next one. It's a degree 5, okay? So notice anything 4 or more, we're going to call whatever the number is, 4th degree, 5th degree. In this case, since it's a degree 5, we're going to call this a 5th degree. Now there is really a special name, but we're not going to learn anything past cubic. So anything 4 or higher, we can call 4th degree, 5th degree, whatever. And then count the terms, 1, 2. There are 2 terms, making this a binomial. 5th degree binomial. Okay, problem number 5. Problem number 5 is also 5th degree. One, 2, 3 terms, making it a trinomial. Okay, I think you get the idea now, right? Let's bring this to the front. Okay, there we go. That's good enough. Number 6. 6th degree, right? 6th degree trinomial. Okay, so what's one that's different? I mean, that's pretty much it. I guess number 8. Let's do number 8. Number 8, sometimes people have a hard time with because they don't see a variable. There isn't a variable. In fact, you could think of it as x to the 0 power because there is no variable. That is a degree 0, which makes this a constant. Okay, think about it. The number 10 is a constant number. It doesn't change because there is no variable. So that's a constant, and then there's only one term, so that's a monomial. Constant monomial. All right, I think you get the idea. Let's move on. Describe the end behavior of each function. When we look at these, we can graph them, we can do all sorts of things to them, but you should be able to just look at it and tell kind of what the graph looks like. So end behavior is what it looks like on the 2 ends, okay? So here's what you're going to look for. All right, it's kind of the same thing, but not quite the same thing as what we just did. You need to look for this number right here. I don't really care that it's a 4. What I care is that it's even. All right, that's an even power. It's an even degree. It's a degree 4, but I care that that's an even number. And then the number in the front is 1 right here. I care that that's positive. All right. This is a positive and even graph, okay? And so It's a positive coefficient a with an even degree. So what's going to happen? Think about when you graph like an x squared graph and an x squared graph made a parabola. All right. All I really care about are the ends that are going up and up. I don't really know what's happening in the middle here, but that's what's going to happen on an even function like this. All right. An even function means that either both arms are going up or both arms are going down. So in this case, it's an even. So it does like a parabola does. And since it's positive, they're going to go up. So that's it. That's the answer. Okay. Next one. Odd and positive. Okay. So think about a positive slope. A positive slope goes like this. It goes uphill. Okay. But in this case, when it's odd, the end behavior, one of them is down and one of them is up. Okay, that's it. That's the answer. Now, I know I haven't given you a lot to go by so far, but keep looking at the examples. Okay, this next one, even and negative. All right, so think about that. Number 11 was even and positive. Even means the arms do the same thing. Okay, down and down. Okay, negative makes them point down. Next one is odd and positive. Odd and positive, well, that's going to do the same thing as 12. Down and up. Okay, notice I'm skipping the middle because I don't know what's happening in the middle. Something weird could happen. I don't know. All right, next one. Odd and positive. It's going to do the exact same thing as number 12 and 14, odd and positive. Odd just means that the two arms do something different, and positive means it goes uphill like a positive slope. Next one is even, so the two arms are the same, and negative, so they point down. That's going to go down and down. Even and negative, just like number 13. Okay, just like number 13. Next one, odd and negative, all right? So it's a negative slope. Negative slope goes downhill, right? Okay, so since they're odd, they do something different. You got to make them go downhill, so they're going to go up and down like this. That's the end behavior. Next one, even and positive. Well, we already have an even and positive like problem number 11. Problem number 11 was even and positive. Up and up. Next one, same thing. Up and up because it's even and positive. Next one is odd and negative like number 17. Up and down. And that's it. That's the lesson.